perimeter. This is the last example on the 9-2. We just didn't have time on Friday because we had that weird schedule because of the PSAT practice or whatever. So this guy is a triangle. We're going to find area and perimeter. So you can actually, if you want to, we could find the perimeter of this immediately, right? Because we know this side's 12, this side's 12, this side's 20. So perimeter is just to add up around the outside. What would my perimeter be for that? 44. All right, so we can get that without even doing the problem. So there's your perimeter, and it's labeled in meters, so the little line already has that label. Now the area here, a little bit trickier. If, let me see if you guys remember this from first semester. Okay, so what kind of, if you just ignore that for a second, if I know both sides are 12 there, what kind of triangle is this? If you got two sides that are the same length, do you remember what that means? This is definitely obtuse if you would look at this, but like what kind of, based on the sides, what kind of triangle is that? Isosceles. Okay, this is isosceles. Now, this is the reason I'm asking you this. If you have a height that is drawn from the vertex of an isosceles triangle between the two sides are the same, do you guys know what that does to the side across the bottom here? If I have this in an isosceles triangle, it's the vertex there is between the two sides are the same. Do you know what that segment does to the base of the triangle? Cuts it in half, exactly. Okay, so that's going to help us here. So on either side, like this would be 10 and this would be 10. How could I figure out, right, because for area, I'm just going to write this to the side, we either want to do 1/2 base times height, or if you like the other one better, base times height divided by 2. I have the base of the triangle, right, just from the original problem is 20. I don't have the height, so we have to figure out the height. How could I figure out the height of that triangle based on what we know from the picture? Anything that you can think of? Yes. Okay, how would you set up your Pythagorean theorem? Exactly. You could make an argument on either side here. I'm just going to color one of these real quick. This and then the triangle that I just didn't color that make up the whole thing. They're just two little right triangles. You got that right angle from the height, so you can just do Pythagorean theorem. So this is just a little review from last week. Now, just the base of this triangle, or the leg, is 10. So just 10 squared plus h squared. The hypotenuse would be across from the right angle, so that's actually the 12. So you got 100 plus your height squared, 144. I'm going to subtract 100, and we're just going to practice this today. We're going to leave this in radical form because that's what the questions are going to ask you to do. If you take 144 minus 100, you're going to get 44, which is not a perfect square. But to solve this, we would have to take a square root. So we want to leave this in radical form. Okay, so I'm just going to recommend this to you guys because I think this might be so much easier than a factor tree. Okay, and I'll put these up on the board, but I'm just writing a couple of the perfect squares. This is how I learned how to break down the radical. If you have a perfect square that can divide into what you're working with, we're working with 44 here. Can you, and I could make a laundry list of numbers and keep going. This is just 1 squared, 2 squared, 3 squared, 4 squared. Can anybody tell me biggest number on that list that would divide into 44? 4 times what? Okay, so I'm just going to rewrite this really quick as it has to be multiplication, not adding or subtracting. So what is the square root of 4? 2. And so you just take the square root of that perfect square, the 11 would stay under the square root. I just think that's so much faster than trying to make a huge factor tree with this. So if you want to break it down with a factor tree, please do that if you like that better. But if you can figure out the biggest perfect square and then take the square root of that biggest perfect square, then you can simplify it maybe a tiny bit faster. So now I know the height. So the height is 2 roots of 11. So if you have to leave this in radical form, for my area here, do you guys like the 1/2 base height, or do you like base times height divided by 2 better? Or it doesn't matter? Doesn't matter. Okay, so I'll just do 1/2. The base is 20, and then that height is 2 radical 11. Now, you're going to see this on a bunch of the questions today. It's just going to say, leave it in simplest radical form. So literally, all you would do, you would just, on your calculator, do like half times 20 times 2, and just write the square root of 11 next to it. Now, half of 20 is 10. Multiply that by 2 would actually be 20. So the area is just going to be 20 roots of 11. And that's simplest radical form. You don't have to do anything else. You don't have to break, 11 doesn't break down under the square root, but the questions today are going to ask you to leave it in radical form. Now, if you're like thinking that doesn't make a lot of sense to you or whatever, you can always just, if you want to check out what the decimal is on the calculator, I'm just doing 20 times the square root of 11. As a decimal, this would be about 66.3 meters squared, just if that makes a little bit more sense to you. But most of the questions are going to ask you to leave it in radical form because that's considered an exact answer and I'm not rounding anything. And we're going to move on and do the 9-3 today, but I wanted to definitely make sure I went over this with you guys because there's a question like this on the test and the quiz in this unit. So let's try another little example here. This will not take long. This lesson's pretty short. So 9-3 is split into 2 days. We're going to talk about what we call special right triangles. So today we're going to talk about a 45, 45, 90, and tomorrow we're going to talk about a 30, 60, 90. So everything here today is going to be a 45, 45, 90 triangle, including this very first question right here. So this is a situation, our 2 legs of that triangle are the same. They give you the hypotenuse. So it doesn't matter here what the angles are, but we're going to find the area and the perimeter. To find either one of those, we got to figure out what x is. Okay, because this lovely guy is a right triangle, then I can just use the Pythagorean theorem here. And I know this is a little weird, but the 2 sides are both just x, the 2 legs. So if I was doing Pythagorean theorem, the 2 sides that make up the right angle are one side of that Pythagorean theorem. They're both x. So I'm going to do x squared plus x squared has to be 15 roots of 2 squared. What, can I simplify x squared plus x squared on that left side? Like, can I actually add these together? What would it be? It'd be x to the 4th if we multiplied it. So if we think about this, like this is just 1x squared plus 1x squared. How many x squareds do we have? 2. So that's all you would do. This would be 2x squareds. Okay, now if you want to grab your calculator, you can. If you want to do this by hand, you can. It's completely up to you. I'm going to just write this to the side. If I do 15 radical 2 squared, it means I'm multiplying 15 radical 2 by itself. And I know this is a little bit weird, and again, you want to use your calculator, go right ahead. But if you're multiplying something by itself, you're going to multiply 15 times 15. It's going to give you 225. And square root of 2, I'm just going to squish those together. Square root of 2 times square root of 2, you just do 2 times 2, which is square root of 4. Now, the nice thing that happens here is 4 is a perfect square. So really, this is 225 times 2. So when you square that hypotenuse that they had there, when you do the Pythagorean theorem, it's actually just, this will be 450. So it's a nice number when you do that. And you guys can use your calculator if you want to. Now, all I'm going to do to solve this is 2 steps. Don't take the square root yet. You want to get rid of the 2 first. You want the x squared all by itself before you take the square root. So just divide by 2. And this is actually going to give you 225. Now, 225, I don't know if you guys know this. This is a perfect square, though. Does anybody know square root of 225? It's 15. Yes. Okay. So that means that both legs in my little triangle are just 15. Now, if we have to do area, then area is just 1/2 base times height, or base times height divided by 2. So however you want to do that, 1/2 base times height. If you have a right triangle, which we do here, the height and the base for any right triangle, they actually make the base and the height of the triangle to do your area because they intersect at a 90-degree angle. So for this question, if I'm doing area, it's just 1/2 times 15 times 15. The base and the height are actually exactly the same here. You guys are actually going to see this on some other questions today. This does not give you a nice number. This gives you 112.5. So don't think you're doing anything wrong if you get a decimal. So 112.5 and then units squared, since they don't have any label in the diagram at all, like inches or anything like that. Now the perimeter is a teeny tiny bit weirder. So the perimeter says up here in the directions, just leave this in radical form. So you have all three sides, right? One side's 15, another side's 15, and the hypotenuse is 15 radical 2. So to add these together, just the two plain numbers, and I know this is weird because they're like all got a 15 in them, but 15 is 30. And then we would keep this other piece, this 15 radical 2, you would just keep that separate. And so it would be two terms like that. You can't add a plain number to a number that's attached to a radical. We could multiply them, but you can only add them if they have exactly the same thing under the square root. So just two separate terms for your perimeter there. That's a little bit weird. Now, you guys didn't necessarily know this, but you just worked with a 45, 45, 90 triangle in there. So I'm going to show this to you, kind of relate it back to that question. So whenever you have a 45, 45, 90 right triangle, two of the sides are the same. And if you look back to this triangle here that we just looked at, like the two sides that form the right angle, they were both 15. And then the hypotenuse was 15 times the square root of 2. This is an actual little formula for this, and I'm going to write this down. This is an isosceles right triangle. 45, 45, 90 is also an isosceles right triangle. It just means two sides are the same, and it means we got those 45-degree angles. Now, if you notice this, these two sides where I have the letter S, these guys are both called the legs of the triangle, and then the side times the square root of 2 is your hypotenuse. So if you notice here, like I have just S for the side, S, the two sides are the same. The hypotenuse is the leg or the side times the square root of 2. It's the exact same thing up here. You have two, these are both 15. That side is 15 radical 2. So they're related. So there's kind of two little things I would jot down for solving any kind of isosceles right triangle. If you know the leg, you can get the hypotenuse. I'm sorry, if you know the hypotenuse, you can get the leg by dividing by the square root of 2. So if you know the hypotenuse, the leg is going to be the hypotenuse divided by the square root of 2. The other formula for this would be that your hypotenuse, if you don't know that, but you do know the leg, is the leg times the square root of 2. So those are kind of the two things that would go on for these problems. And some of these can be really quick and easy, and some of them can take you a little bit to do. It just depends on what they give you in the question. So I'm going to slide down here. Two sides are the same. And then the hypotenuse is going to be the side times the square root of 2. So if I know this is a 45, 45, 90, if this is 9, I know it doesn't ask you for this, but automatically this is also 9. So in this case, I don't know the hypotenuse. So the leg times the square root of 2 is equal to the hypotenuse. So literally all you have to do here, this is not bad. You don't know the hypotenuse, they call that h in the diagram. You do know the leg, it's 9. And you would multiply that by the square root of 2 to get the hypotenuse. That's literally all you have to do. This is the answer to the question. That's it. Now some of the rest of these will be a little trickier, and this is why I was having you guys review the radical stuff last week on Friday. So that's what we're going to practice in the next couple. They're a little bit harder. So some of these on the homework, they might just be this easy, just like I have here, but some of them are a little trickier. So if you look at the picture in the middle, these two sides that make up the right angle, they both are across from 45-degree angles. They're both going to be the same. So I know they don't have it in the picture, but that leg up there, kind of between the writing and the diagram, that would be 2 radical 2. Now this time they call the hypotenuse x in this diagram, but I would actually use the same exact little thing. So the hypotenuse is your leg times the square root of 2. The weird part to this question is what your leg is equal to. So they called the hypotenuse x. Your leg is 2 radical 2, but then I would multiply that by radical 2. Okay, how can I simplify 2 radical 2 times radical 2? Okay, Jaden says 2 radical 4. He's totally right. All right, you keep the 2 on the outside. Radical 2 times radical 2. You can always just squish those together, just multiply the numbers. That becomes square root of 4. Now, the nice part of this was the square root of 4. Dose, right? So it's just 2. And so actually in this case, the hypotenuse is just going to end up being 4. So you might have to do a little bit of work. That's why we practiced with those radicals last week. But you got to just identify what you have in the problem. All right, now this one is a little bit tricky because we have the hypotenuse. So in this diagram, the 2 legs would actually be x. Now, if you wanted to, with the 45, 45, 90, you could actually go through this and do the Pythagorean theorem to find the missing side. It would be really similar to the very first question we did at the beginning of class today. If you want to use the Pythagorean theorem, or you can use the little 45, 45, 90 formula. It's totally up to you. In this case, I don't know the leg. The 2 legs are missing. But if you know the hypotenuse, you can get the leg by dividing the hypotenuse by the square root of 2. Now, this is a bit like what we were doing on Friday with the rationalizing. So, I don't know the leg. The leg they call x in the diagram. I do know, however, the hypotenuse, which is 6. So I'm going to divide that by the square root of 2. So, not allowed to have a radical in the denominator. Yes. Does anybody remember how to get rid of the square root of 2 in the bottom of that fraction from what we were doing on Friday? Like, what do you do to call it rationalizing the denominator? How do I get rid of that root 2? Brody, what do you think? Perfect, perfect. Just copy whatever's in the bottom. If you're working with one of these, it's probably going to be radical 2 unless it's like a weird problem. Now, on the top, and I'm going to simplify this, it just literally keep the 6 on the outside, radical 2 on the bottom. The entire purpose of this is to create a square root on the bottom that will cancel out, which if you multiply root 2 by root 2, you get root 4, which is a perfect square. Whenever you multiply a square root by itself, it creates a perfect square. That eliminates the radical in the bottom. Now, I'm going to ask you a quick question, and it depends on the problem. Do not touch the radical, so don't touch that square root of 2. Can I divide 6 by 2? You can't. So you can actually simplify this just a little bit. If that number is ever even and you have a 2 in the bottom, you can actually reduce that. So 6 divided by 2 is 3. What you would do to write your answer here, it would just be 3 roots of 2. Just don't change the radical. Just that stays right there. But 6 divided by 2, that is 3. And so this actually would be my answer for my length of my leg there. All right, now, each one of these is just a little bit different. This one doesn't have a picture. And it says, find the length of a leg, so of a 45, 45, 90. I'm just going to try my best to try and sketch a picture. 2 legs are the same. And it says the hypotenuse is the square root of 10. All right, so there's my leg. So, all I have to do here, your leg is your hypotenuse divided by the square root of 2. So this is actually similar to the question we just did, but it's going to look totally different algebraically because we have different information here. So I called the leg x in my picture. My hypotenuse is root 10, so I'm going to divide that by root 2. Does anybody know what that would actually be? Can you divide 10 by 2? Yes. All right, if you have both pieces of your fraction, like the top and the bottom under a radical, this can really be like square root of 10 divided by 2. So 10 divided by 2 is 5, right? It's just under the square root, and that is your answer. That's not something you can do anything else with in terms of simplest radical form. It's in simplest radical form, square root of 5. That's it. So it depends on the question what they give you. It might be a little easier or a little trickier depending on the problem. All right, this one, I don't, again, have a picture, so I'm going to just sketch you a picture. 45, 45, 90. So the 2 sides that make up the right angle, those are the same length. I'm just eyeballing it. I'm sure it's not perfect. But it says find the hypotenuse, so let me just call that h because I don't know the hypotenuse there, and the lengths of the legs. So both of these guys would be 5 radical 6. And this one would probably be the one you'd have to do the most work on any of the problems today. So here, the hypotenuse is the leg times the square root of 2. Right? So if I know the leg, all I got to do is multiply it by the square root of 2, and I'll have my hypotenuse. So I called the hypotenuse h in that lovely little picture. My leg was 5 roots of 6, and I got to multiply that by the square root of 2 anytime I want the hypotenuse, just the leg times the square root of 2. If I do 5 times the square root of 6, and then I multiply that by the square root of 2, what would that become? Or can I do anything with that? Let me have you look, let me look back at part B. So you can always multiply radicals. So if you've got, I've got a number in front, I got kind of a similar thing here. It's a little bit different problem, but I'm just going to multiply the numbers under the radical, just like I did up in part B. So you keep the 5 out in front, you just do 6 times 2, and that's 12. Now 12 we could break down with a little factor tree, or if you want. Just try this for me, because I think it's a little easier. I'm just going to write some perfect squares. And I have this typed on your homework for you, so you guys will have it. What is the biggest perfect square? I only went up to perfect squares that go up to 5 there. What's the biggest perfect square that would divide into 12? 4. 4 times what? There you go. Perfect. So 12, 4 times 3, right? Okay, if you can rewrite it as the product of a perfect square, and whatever it is, in this case it would be 3, you can just pull the perfect square out. So square root of 4 would come out as a 2. If you happen to have something in front already, which we have that 5, you just multiply these guys together. So 5 times 2 is 10, and the 3 stays under the square root. That would be my answer. Is anybody having a question? Okay, I'm going to give you a little bit of an application problem here on the back. This says, we got a couple of these. This is not bad to do, I promise. All right, so it says the distance from one corner to the opposite corner of a square playground is 75 feet. So let me just real quick mark this. Each of the sides would be exactly the same if you have a square. And I've got the diagonal drawn in, but I'm going to just mark these corners just real quick. Whenever you have a square, all the angles are right angles, so I'm just going to mark those two guys. Basically what you have here, if I cover one of these up, right, I have a 45, 45, 90, because these two sides are the same, and I have the hypotenuse of that 45, 45, 90. So the leg would be every single one of the sides in the little square that we have there. So your leg is your hypotenuse divided by the square root of 2. So we have the hypotenuse there. The hypotenuse is that 75. All right, so I'm just going to plug this in. I'll call the sides, let me just go back in here, and I'll call all the sides x, because they all have to be the same if that's a square. So any one of those legs would follow this little formula. The 75 is across from the right angle, so that'd be the hypotenuse if I just looked at one of these as like a little right triangle here. So 75 divided by square root of 2. This is similar to a question we did on the front, but it's a little bit different. So I'm going to rationalize this. Can't have the square root in the bottom, so we're going to multiply top and bottom by the square root of 2. That's really multiplying by 1, but this will give us a situation where we don't have a radical in the denominator. All right, so across the top, I got 75 roots of 2. Root 2 times root 2 is root 4, which is then a perfect square, and the square root of that 4 is going to be 2. So, different from the question on the front, we had like one that was like 6 roots of 2 over 2. You can't divide 75 by 2, right? It's not a nice number. It's not an even number. So this is my leg. Now, if we're going to find the perimeter, and you can grab your calculator to do this if you want to. If we're going to find the perimeter, how many sides do I have in a square? How many sides do we have in a square? 4, right? Okay, all you're going to do, each one of those sides is the same, right? It's that weird number, that 75 root 2 over 2. I promise this is not hard to do. So we're going to take 4, and because it's a fraction, I'm just wanting you to think about it as 4 over 1. We're going to do times 75 roots of 2 over 2. Now, all I would do on the top of that fraction, I would do 4 times 75. 4 times 75 is 300. And we would just have the radical 2 next to it. On the bottom, you just have 1 times 2, so that would be 2. Now, in this case, don't touch the radical. 300 is divisible by 2, so you can reduce this. 300 divided by 2 is 150, and it would just have the square root of 2 next to it, and then you're done. That would be your perimeter. And I'm going to put feet next to it, because that's the label they gave you in the diagram. Does anybody have a question? Okay. This guy is an isosceles trapezoid and wants you to find the perimeter in simplest radical form. So let me just highlight what I have here real quick. The only part of the perimeter I have given to me in that diagram is that top side of that, the top base is 8. Okay, let me highlight another little segment here. What would the length of that segment be that I just highlighted? Also 8, right? So I'm going to use that. Okay, now here's what I'm going to show you to the side. So if I have that 45-degree angle, these two little triangles are going to be identical, because if I've got a right angle, like where I've got the right angles labeled, this would also have to be a right angle. So this forces both of these little guys to be 45, 45, 90. So this would be 6. Can anybody tell me like what the bottom of that triangle would be? It's 6. These are the two, right? These two guys are the two legs in a 45, 45, 90, so they have to be the same. So this will be 6. That'll give us another piece of our perimeter. And it's an identical triangle over here. So if this is 6, this is also 6. Okay, now this guy, this only other side, I don't have these two sides, but they're both going to be the same. If I have the leg in a 45, 45, 90, what would the hypotenuse be? Brody, what do you think? Yes, just the leg times the square root of 2. So this is just 6 radical 2. Now, the main problem that people will screw up when they do a question like this is they add like literally every number they see in the diagram. If you're doing a perimeter here, just go around the outside. And this is a little bit weird because you've got these radicals in here, but it's not terrible. It'll just be 2 separate terms, kind of like that very first problem. So plain numbers around the outside, I've got an 8, and then across the bottom you've got a 6, an 8, and a 6. And then I've got that 6 radical 2, 6 radical 2. Plain numbers, add those guys up. Let's see, we have 14 and 14, so we got 28. Okay, now, this is a little bit tricky. We didn't do a lot with this. I can add these two radicals together. I'm not multiplying anything, I am adding them. So if you add them, 6 roots of 2 plus another 6 roots of 2, this would simplify to be 12 roots of 2. And I had somebody at like, why am I not multiplying? If I just, a little side problem, if I just told you, hey, we're going to do 6x plus 6x, right? You would not tell me this was 12x squared. You would just tell me you have 12 x's. It's the same concept here. You have 6 roots of 2 plus another 6 roots of 2, so you have 12 roots of 2. You don't change what's under the radical if you're adding or subtracting, only if you're multiplying. So I know this is kind of complicated, but that would be the perimeter, those two separate terms. The 28 plain number, and I can't add that to the 12 radical 2 because we don't have a radical attached to the 28, so it just has to say it's 2 separate terms. That's an exact answer. We're not rounding anything by taking a square root. Okay, now I'm going to slide down here real quick. I'm going to sketch you a picture of a square. It says the perimeter of this square is going to be 44. If I tell you the perimeter is 44, how would you find the length of the side? If you know all the way around the outside is 44, how would you find the length of one side of the square? Divide by 4. All right, so all we're going to do, 44 divided by 4. So each of the sides would be 11. All right, now it says find the length of a diagonal. So I'm just going to sketch a diagonal into my picture. And if I'm working with a square, those have to be right angles. The other thing, if you're working with a square, it's like a rhombus. The diagonal bisects the angle that it runs into. So I'm running into a 90-degree angle in either corner that I got drawn there, which would split that into 45 and 45. So basically a square is just two 45, 45, 90 triangles squished together. Can anybody tell me the length of that diagonal? So I'm just going to draw one of these triangles separate real quick. You have your leg is your side, your other leg is the same side, and your hypotenuse is that side times the square root of 2. What would the diagonal be? So what I have in my picture, this is a 45, 45, 90. These guys are both 11, and this is the diagonal. So what would the diagonal be? 11 square roots of 2. That's all you have to do. You're done. That's it. It's not terrible. All right, now I'm just going to give you the same kind of a question, but like a little bit different piece of information. So this is the area. The area of a square is 289. So we know if we have a square, all the sides are the same, right? So let me just draw another sketch right on this one here. Right, all the sides would be the same. How would I figure out the side length of the square if I know the area? I know the area here is 289. How would you find the length of the side? If I just told you all the sides were x, and I didn't give you the area, how would you find the area? Brody, what do you think? Base times height, right? Okay, now, the deal is with the square, the base and the height are exactly the same because all the sides are the same. So we'd have x times x. What do I get if I multiply x times x? X squared. Okay, so that would just, in general, that'd be for any square, right? For any square. Now, if I know the area is 289, and that's going to be equal to my side squared, how would I figure out the side length? Like, what would you do to the 289? Take the square root. And it is a nice number, actually. If you take the square root of 289, let's see, should be 17. Perfect square. All right, now, so all my sides are 17. If I ask you for the diagonal, again, if this is a square, each one of these triangles would be a little 45, 45, 90. What would your diagonal be for that picture? 17 radical 2, and then you're done. It's just kind of two different ways to get there. One gave you the perimeter, one gave you the area. Is anybody having a question?